Welcome to the Deep Dive, where we take a stack of your source material, we dig in, and we pull out the essential knowledge you need. And today, we are venturing into, well, let's just say it's the most unglamorous part of owning a home.
Yeah, that's putting it mildly.
We're talking about the septic system. Now, most people, when something goes wrong, they just assume it's, a clog, or maybe the system's just old.
Right. They call a plumber in a total panic, bracing for a huge bill to replace a drain field.
But the sources you send over point to something completely different, something that can cost you tens of thousands of dollars if you ignore it, and it's not mechanical.
It's not. The biggest revelation here, the real aha moment, is that the problem is almost always biological.
Biological. Okay, let's unpack that. We think of a septic tank as this, concrete box that just holds waste, a storage unit.
And that's the core misconception.
Yeah.
It is absolutely not a storage unit. A septic tank is a biological processing unit.
A processing unit.
Exactly. Its health, the health of the entire system, is run by this invisible ecosystem of, and this is key, good bacteria. When that biology is happy, the system works.
Yeah.
When it's not, everything grinds to a halt.
So our mission today is to get to know this microbial factory floor. We're going to look at what these bacteria actually do, why two very simple chemical factors, oxygen and pH, are so critical, and how modern septic care is shifting to supporting this biology instead of, fighting against it.
To start, we should probably look inside the tank itself. Picture it. You've got 3 layers.
Okay.
The heavy solids, they sink and form a sludge layer at the bottom. Then you have oils, grease, that kind of stuff. Floating on top is scum.
Right.
But it's that middle layer, the liquid they call effluent. That's where all the action happens.
So it's not just wastewater waiting to go somewhere.
Not at all. That effluent is the workplace. It's where the beneficial bacteria live. And their job is to digest all the organic matter coming in.
Digest it into what?
Into much simpler, mostly liquid substances that can safely flow out to the drain field. This breakdown is non-negotiable. If raw solids get out to the drain field, it's game over. You get clogs, and they are basically irreversible.
So a system failure is really a biological slowdown that just looks like a plumbing problem.
That's the perfect way to put it. The bacteria just can't keep up. And to understand why they slow down, you have to meet the 2 main types of bacteria that are in there.
Okay, so let's start with the ones that are already there by default. The anaerobic bacteria.
Anaerobic bacteria. Yeah, they're your base layer. They thrive without oxygen, which is why they dominate in the sealed tank.
Sure.
They do the job, but they do it slowly, inefficiently.
They're the low-speed workers who, I guess, leave a big mess.
A huge mess.
Okay.
And that mess is what causes all the classic symptoms of septic failure.
Like what?
Well, their slow digestion means you get a ton of sludge buildup because they can't fully break down the solids. And crucially, their process creates those really foul, sulfurous odors.
Ah, the rotten egg smell.
That's the one. Hydrogen sulfide gas. If you smell that, you're hearing the sound of an oxygen-starved, struggling system.
But there's another team we can bring in, the aerobic bacteria.
These are the superstars, the A team. But they have one requirement. They need oxygen to live.
And the difference is that significant.
Oh, it's staggering. Some of the research suggests aerobic bacteria can be up to, get this, 100 times more effective at digesting organic solids than the anaerobic ones.
100 times.
They're faster, cleaner, they produce way less sludge, and their process doesn't create those terrible odors. The water leaving the tank is much cleaner.
So it sounds like the whole goal of modern septic care is just to figure out how to get these aerobic bacteria to thrive in there.
That is the entire game. But you can have the best bacteria in the world, and they won't do a thing if the environment itself is hostile.
Which brings us to those 2 chemical factors you mentioned, oxygen and pH.
Exactly. They decide who wins the battle inside that tank.
Okay, so let's start with oxygen. Why is it such a game changer? A sealed tank is naturally oxygen poor, so how much difference can it really make?
It makes all the difference. We know traditional tanks are slow and stinky because they lack oxygen. The science on wastewater treatment is really clear on this. When you introduce an oxygen-rich environment, the metabolic speed of these bacteria it skyrockets.
It's like giving your workforce a turbo boost.
A turbo boost is a great way to think about it. They process more waste way faster. So oxygen isn't just a bonus. It's really the key to having a fast, clean, efficient system.
And it neutralizes the odors, too.
It allows the aerobic bacteria to take over,
Yeah.
and their process doesn't produce those smelly gases. But, like you said, oxygen is only half the battle.
Right. The other factor that nobody thinks about, pH balance. You could have all the oxygen in the world, but if the water is too acidic or too alkaline.
The whole ecosystem just shuts down. There's a very narrow comfort zone for these microbes. The sweet spot is a neutral pH, right around 6.5 to 7.5.
And if it drifts outside of that.
The bacteria either go dormant or they just die off. The whole breakdown process stops cold and sludge starts piling up like crazy.
And the really cruel irony here is that we, the homeowners, are usually the ones causing the problem.
We are the biggest culprits for sure.
Mm-hmm.
We're essentially waging chemical warfare on our own microbial workforce every single day.
How? With what?
Think about it. Harsh household cleaners, chlorine bleach, disinfectants, antibacterial soaps.
Mm-hmm.
When you pour that stuff down the drain, it's like a bomb going off in the tank. It shocks the system. Even, heavy use of certain high alkaline laundry detergents can throw the pH completely off.
And just waiting for it to fix itself doesn't work.
No. The research shows that once that balance is disrupted, just waiting it out usually makes the problem get much, much worse.
So let's connect that biological stress to the symptoms, the things that make a homeowner finally pick up the phone. How does that imbalance show up on the surface?
Well, you start to get those really persistent, powerful odors inside the house and out. Your drains get slow, you hear gurgling in the pipe.
The system is backing up.
It's backing up. You might even see wet patches or, extra green, soggy soil near your drain field. That's a really bad sign. It means raw effluent is surfacing.
And you end up having to get the tank pumped way more often.
Exactly, because solids aren't being digested. So when people see this, the old school approach was just panic and aggression.
Mm-hmm.
Grab the harshest chemical you can find.
Right. Pour something down the drain that promises a quick fix.
And that often made the long-term problem so much worse. Those chemicals are indiscriminate. They kill everything.
The good bacteria along with the bad.
You're obliterating the very ecosystem that's supposed to be doing the work for you. It might mask the symptom for a week,
Yeah.
but you've just destroyed your workforce.
Which is why the modern approach is so different. It's not about chemical attack. It's about biological support.
It's a total shift in philosophy. The focus now is on supporting the existing bacteria, giving them the oxygen they need, and stabilizing the pH so they can do their job.
So let's talk about how that actually works. The sources mention solutions like SEPTIFIX as an example. How do they create that ideal environment?
The whole design principle is about environmental enhancement. The goal is to give the good bacteria everything they need to thrive and multiply on their own.
And the key is getting that oxygen into a sealed tank. How do they manage that?
The mechanism is really clever. It's designed to release oxygen gradually over time once it's flushed into the tank.
So it's not just one big blast.
No, it's a controlled, sustained release. And that's critical. It activates those super efficient aerobic bacteria and gives them the conditions they need to start multiplying. At the same time, all that oxygen suppresses the slow, stinky anaerobic ones. You're basically engineering a shift in the microbial population.
So you're not adding a chemical to kill things. You're changing the environment to encourage a whole new, better workforce to grow on its own.
You got it. By fixing the oxygen and helping stabilize the pH, you're allowing the system to self-regulate, to heal itself in a way. The result is just a much more efficient digestion cycle.
And the big benefit for the homeowner, for you listening, isn't just that it works better today. It's the financial protection it offers down the line.
Absolutely. When your bacterial efficiency goes up, your sludge accumulation goes way down,
Less sludge means a cleaner liquid leaves the tank.
which is the key to protecting your drain field from clogging. And a healthy, unclogged system means fewer expensive pump outs, and most importantly, it dramatically lowers the risk of a catastrophic drain field failure, which, as we said, is a repair that can cost a fortune.
So when we boil this all down, what's the big takeaway? It seems to me that a balanced septic system is the ultimate form of preventive care, not damage control.
That's it, exactly. It's about longevity and cost avoidance. When you get the biology right, when the bacteria, the oxygen, and the pH are all aligned, the system is just. It's elegant, it takes care of itself. Modern solutions are just optimizing that natural process.
Septic problems don't just happen overnight. They don't start when a pipe breaks. They creep up slowly as that biological balance erodes over months or years.
Yeah, this is a slow decline.
And the real power of understanding this science is that you get to be proactive. You can support your system and prevent the disaster instead of just reacting to it.
It's always better to work with nature, not against it.
So think about that for a minute. The next time you reach for a bottle of some industrial strength bleach or cleaner, you've got this complex, silent biological machine working for you right under your lawn. And knowing that just a small amount of the wrong stuff can wipe out that entire essential workforce, it should make you pause.
A very small change in your habits can mean decades of a healthy, hassle-free system.
The real lesson here is to respect that invisible ecosystem because its health really dictates the health and the expense of your entire home. That's it for this deep dive. We hope this gives you a new appreciation for the hard work being done by the invisible team right beneath your feet. We'll see you next time.